So without further ado, let's welcome our first speaker, Ashish Kedia. Ashish is staff software engineer at Google, where he works in the workspace security team. He has more than a decade of software engineering experience. As part of his role, he has developed several large-scale automated testing stacks, including performance testing, regression detection, scalability verification, and fuzzy testing. So here we have Ashish Kedia with fuzzy unit testing. Really excited to have you here, Ashish. Welcome.
Hi. Yeah. Thanks for the introduction. Yeah, I'm glad to be here. So today I'll be talking about fuzzy unit testing. It's something we use very often at Google, specifically for newer systems. Uh, so jumping straight to it, I think all of us are likely aware of what like unit tests are. So a good unit test structure is typically arranging three different parts. So one is arrange, second is act, and third is assert. In a typical unit test, the arrange section is where we kind of like set up a test environment, we kind of mock dependencies, we create the necessary input objects. Act is where we invoke the code under test, is where we are making a method call into the system under test using the data that we prepared, using the environment that we prepared in the arrange section. And the last is the assert section, where we kind of verify that the act section performed as expected. This involves like checking return value, object state, mock interactions, and all the other typical ways of making sure that your system under test is behaving the way it should. In particular, for fuzzy unit testing, the most important part is arrange. Uh, as a sample test, right? Let's test a code that's like trying to like convert a hard book into an ebook. Here, the arrange section is where like we create the test object. The act section is where we actually invoke uh, the system under test, and assert is where we are actually asserting some properties of the returned value based on the input value. This is a very simple snippet example. Now, what happens in an arrange section is that we typically have to create a lot of test data. This is a very simple example, but in a real life testing scenario, we often have to create a lot of input values, a lot of data structures that can be nested, and the creation of it can be very boilerplate heavy. Every object has to be created by hand, and many of the times some of these data structures will have like many required fields. For example, in our example, book has like an author and title requirement. So even though they are not relevant to our act and assert section, we still have to populate them because like the author and titles are required. So arrange section can often get like very boilerplate heavy. And also when writing a suite of tests, arrange section tends to look very similar to each other. If you're writing like 10 unit tests for a given class, many of them will have like very similar test data, and thus will have like very similar arrange section. Uh, Typical solutions that exist for this is many folks create like util classes or like factory methods to generate these test data. Many times we generate like we create like text files containing the test data, and we also many times filling in like sentinel values like we have done in the example above. We have just filled in the author and the title with some sentinel value. It has no meaning or no relation to the test itself. Uh, so all these existing ways of generalizing arrange section, they all meet, they all violate the completeness goal of a unit test. Like as a reader of a test, you have to kind of look at multiple functions. You often have to look at a different file to really understand what kind of test data is being created, and that can be that cannot be very friendly to read and update. Uh, Also, these kind of abstraction also leads to misleading constants. For example, we often name some of these common test data with like names as like, test data itself, which doesn't really tell us anything about the properties of that test data. And
Excuse
often,
me, Ashish. Sorry,
yes.
we're not seeing your screen. Are you sharing?
I'm sorry, I was sharing, but something went wrong.
Okay,
Uh,
thank you.
yeah, I'm so sorry about that. Yes, yeah, like I was talking about the problems with abstraction, yeah, it can be incomplete, constants can be misnamed, and also it becomes like a maintenance burden because every time you want to update these constants or these common test data, they are often like shared across multiple tests. So updating any of the constant breaks a lot of different tests. This is where fuzzy testing comes in. The idea is very simple. It's just to use some kind of random number generators to generate primitive values, and then recursively use the same random number generator to create like complex, deeply nested value classes and like wire format data. Basically use random generators to create your entire test data except the fields that you really care about. So uh, yeah, typically we wrap these randomness using like a fuzzy factory utility. As an example, rewriting our previous example with a fuzzy generator is we would create like a fuzzy factory which would create like a new book, and all the fields in this new book will be populated like randomly, including the author and the title. So we don't really have to worry about it anymore. And then all we need to care about is because our code under test cares about the cover type of the book being hard. That's the only field we need to override, and rest of all the fields can just be like randomly populated. Now this makes very intuitive sense because the variable name and the we can immediately correlate the variables that we are setting versus the name, and we can immediately reason about the test as to what kind of properties we are overriding. So the behavior of the test should be something related to the overriding property. So this greatly improves they greatly improves the readability as well as reliability of your test because these random values often tend to be more edge casey rather than sentinel values that we're filling. But like typically a lot of we tend to put like 0 for a lot of integers and empty string for a lot of string types, and these kind of things, these kind of sentinel value don't subject your system under test to a lot of like edge cases, and populating them randomly can actually help you discover more edge cases and more expose more unintuitive error. This also makes sure that your code doesn't your system under test doesn't actually rely on accidental unstatic properties of the input data. So yeah, many advantages of it. Uh, one challenge with fuzzy testing is how do we actually initialize these random numbers? One of the principles of unit testing is determinism, and we need to make sure that our test is deterministic, like it's not arbitrarily failing or passing. Uh, and to do this, for teams that are just starting to use fuzzy unit testing, I typically recommend them use a constant seed. When using a constant seed, the values in the test is arbitrary but fixed. So if you run the test like 5 times, they will have the same seed, and therefore all the test data will remain the same, although arbitrary. That still gives you some advantage of testing, but typically the errors are only discovered, like the code under test only fails when the seed is changed. Because unless you actually change the seed, the test data is not changing, so your code under test is not exposed to any new data. Phase two would be to actually generate very random seeds. Typically, we use like time-based algorithms to generate these seeds, and this provides us the maximum coverage because every time your test is running, it's using a new set of data, and there's the probability of discovering an edge case increases. And in order to still keep the reproducibility, we typically also like log the seed every time the test starts or every time a test fails. We kind of log the seed. That way, if the test fails spuriously, we can like just like override the seed and like make sure that we are able to like regenerate the same errors and thus investigate. Uh, Typically, fuzzy testing works when you want to like if you really want to like actually like maximize the possibility of discovering all corner cases. You typically run your test n number of times, uh, and only declare your uh, system under test as pass or success only when all the 9 cases are or only when all the n number of runs satisfy. Test determinism is certainly is a very important property of a test, and if fuzzy testing is not used carefully, this can be a major concern. One thing to note is I always recommend folks to differentiate between like reproducibility and determinism. Reproducibility is very important, and when it comes to determinism, we only need to make sure that the test passes or fails deterministically. We don't really need to make sure that always the same data is used. If your code under test doesn't rely on these random fields or the randomness, then the test results will still be deterministic. Typically, we configure flags or like environment variables to make sure that we can override the random seed chosen in order to like regenerate or reproduce a failed run. Uh, Typically, in modern testing environment where like multiple tests are running in parallel on multiple threads, I also recommend using using different factories for each thread, different factories for each test. Typically, test is a place where we don't really care a lot about performance, and therefore, there are not there are typically not many memory or like latency concerns. So using different fuzzy factories in different tests and different threads is often a good idea. Uh, yeah, thread local fuzzer factories can also help avoid like contention between the random number generator and like lead to like a better determinism, because often like contention can change the values that go into the random test. Yeah. So yeah, typically people ask me, why, like how can tests be deterministic when there's a randomness involved, and I keep giving them the quicksort analogy. For those of us, like many of us might be aware of the quicksort algorithm, it kind of uses a random pivot in the intermediate step. And even though the pivot is random, the result of the algorithm is still deterministic. We can still guarantee that the input is sorted, even though the pivot is selected randomly. And also, determinism should not be confused with coverage, because when we actually use fuzzy testing and we use like random seed, typically derived from wall time, we can also maximize the coverage, because we at every in every run we are actually running the test with like different tests and different inputs, and therefore we are much more likely to traverse all the if and else of our system under test. Some This is not a new concept as such, because there's many randomization pattern that exist in testing industry for a long time. For example, there are several classes of like databases which would typically return a very random order of results unless you actually request that the output be sorted. Uh, one example is like MySQLite, which is very popular database on like mobile devices like Androids. Uh, it typically the test instances they do return like your database entries in a random order unless you have the order by in your query. That way, it prevents your code or your system on the test from relying on ordering without actually explicitly requesting it. There's also hash collection ordering. Order of iteration of hash tables is typically non-deterministic, and but it's not uncommon to find code that relies on a particular order of iteration. So many libraries Google's Guava collection or Google's immutable factories, they all intentionally randomize the order of iteration so that the code under the system under test doesn't rely on it. And then there's also uh, several classes of like frameworks, like web frameworks, like Django, like Python, uh, which actually, uh, in order to prevent test code from relying on order of execution of the threads, it actually randomizes the order of execution of threads in cases where all the threads are started at the same time. That way, it prevents the code from relying on very system specific or machine specific properties. Uh, so this is not a new concept. It's just it has been very niche, used in like very specific cases, and what we propose is using them much more widely for a lot of different cases. That being said, there certainly there are few practical problems with fuzzy testing. Uh, in fuzzy testing, uh, it's there needs to be discipline from dev team when it comes to like investigating the flaky failure. Often many devs team would just rerun a test, and if the test passes, they would just ignore it, ignore the failure, and that's something that kind of mentality is not the right mentality for fuzzy testing, because if a test fails, it does indicate some problem. It's not failing just like that, and therefore it can take a lot of time to actually reproduce the error, and it requires like rigorous investigation. Also, there's quite a bit of capital investment, initial investment that's required for teams who want to use fuzzy testing. They need to set up like the fuzzer utility. They need to set a good pseudo random number generator, and they need to create, often for several projects or several products, we also have to create like domain specific factories that can generate test data specific to a given domain or specific to a given project. Debugging also is can be a bit more challenging with fuzzy testing. It's like sometimes the error message is not very clear, and the line at which your code fails doesn't tell you anything about the failure itself. And the reproducing the failure itself might require you to override some flags or override some environmental variables. Uh, yeah, since the input data is very arbitrary and can be often be very long and less readable, uh, the logs can also be full of garbage that can be hard to parse. And yeah, for yeah, typically for this, I advise folks to use more advanced fluent assertion. So these are like some quick tips if you want to get started with fuzzy testing today. Uh, so there are several fluent assertion tools Google's Truth library available out there. These can be used to assert. So if you're going back to our three three-part testing structure, that is arrange, act, and assert. The assert part can be written, in a fluent manner. If I go back to the example here, we can see that the assert section has been written in a very fluent manner, and this fluency allows the library, the cert library, to actually give you a much better error message as to what they were expecting and what the actual and what the expected values were, and can thus lead to much better error messages. I also recommend folks to use like project level wrappers or project level factories that can easily help us, individual files or an individual tests don't need to write these don't need to generate this commonly used domain specific data types. And it can encourage new devs to actually use fuzzer rather than write the whole test data by hand. It's also important to make sure that uh, we should never rely on two distinct fuzzer value or random values being distinct. Uh, for example, I've seen a very common mistake where uh, entering two entries into two rows in a database with like same primary keys, where the primary key itself is generated using the fuzzer factory. It's very possible that the two random IDs returned by the fuzzer factory can return you the same ID, and therefore like the entire setup fails because the database will not accept the two rows with same entry. So we need to explicitly make this assert about this, and when we want two different IDs, we need to keep generating the second ID until it's like different from the first ID. So ensuring like distinct value can be challenging, and sometimes it's not very clear that you actually need distinct values, and that can be a little bit hard to realize as well as we write. But the more and more we use fuzzy factory in a project, the more such discoveries are made, and eventually like you kind of know about all these dependencies, and the new test will be easily written. Also, fuzzy testing is most effective for continuously run test. Uh, for example, if you are only running test once in a while, when you are changing the code, you are just like running the unit test manually on your local machine, uh, then fuzzy testing may not be very helpful, because again the number of test cases that your system under test will be subjected to will be limited, and also the failure will just be local to you uh, rather than being grounded from like other changes. So it's best to set up some kind of like continuous testing framework which like runs your tests periodically and also every time before like a change is accepted, and that way you can discover a lot more regressions as well. Yeah, that's about it from my end. I will open the floor for any questions.
Thank you, Ashish, for your insightful presentation. Okay, we have here some questions. We've seen fuzzy testing has some extra steps. Is it slower than regular testing because of that?
Typically, no. Typically, performance is not a big concern in most kind of testing unless the test itself is huge. Typically, if you divide the test into like smaller units, it's not way more like the difference in performance is not significant, and it's generally not a problem for most teams.
Next question is, how can we increase test coverage with fuzzy testing?
Right. Yeah, for increasing test coverage, we have to like expose the test to your system under test to a lot of different values, and that can be achieved by running the test multiple times. But also, there are depending on your project, depending on your domain, we can also like generate like coverage guided first value. Typically, you run the test once and you see how much coverage you get. You measure the coverage while running the test, and then depending on the coverage that you get, you reseed the fuzzer. That way, you get more values that cover like more lines of code or more branches of code. Uh, so these are called like coverage guided fuzziness, and there are a bunch of like frameworks available for this in C++, Java, Python, and a lot of different languages.
Thank you so much. We have another question here, as we have some time. What about integration end-to-end tests? Can we use fuzzy data for those kind of tests?
Right. Yeah. Yeah. Integration tests. Typically, we generally don't. I've generally not seen that very well adopted. It really depends on how our integration test is set up. If it's like a hermetic setup where like we are not interacting with any external system, fuzzy testing may work there. But if it's a system which is like interacting with like systems outside your immediate control, it's not a hermetic setup. In those cases, using first value is very hard because often the interaction between your system under test and the external system is often recorded and replayed in a lot of integration tests, and that can make it like very tricky to use like random values.
Well, thank you so much, Ashish, for answering our questions and for your presentation.
Okay, yeah, thank you. Thanks for having me. And feel
Thank
free
you.
to reach out to me, anyone listening to this, in case you have more questions.
Yeah, exactly. If you have any questions unanswered, you can contact the speaker through his LinkedIn profile. Our team will leave it in the chat. I think it's Ashish1294. Is
That's
that correct? Okay.
Yeah.
Thank you so much, Ashish. Thanks so much for being here in WLF Testing 2025.
Thank you. Bye.
Thank you. Bye.